All right, so let's talk 1.1, number 28, which says that we are supposed to find vectors v and w so that v plus w is this thing and v minus w is this thing. And then we're supposed to answer how many unknowns is this and an equal number of equations to find these numbers. Huh. Okay. So what do you do with this? You guys got a plan for me?
Yeah, I mean, you can just break each vector down into its components and make a system of equations.
Yeah, I think that's what I'm going to be after. I'm going to just be like, I don't know what the hell v is supposed to be. I'm going to write it down as something. I'm going to call it v1, v2, and v3. You don't have to pick those letters. You can pick whatever the heck letters you want. I'm just going to say v is that. I'm going to say w is that with w's. So w1, w2, w3. And then I'm going to think, okay, so if I add v and w together, right, I'm going to get, I'm going to get v1 plus w1. That's supposed to be 4. And v2 plus w2, that's supposed to be 5. And v3 plus w3 is supposed to be 6. Okay. And then I think I've got another equation that I could write down. I know that v1 minus w1 is 2. And v2 minus w2 is 5. And v3 minus w3 is 8. And I could proceed to solve this crap, right? Like this whole thing is, well, how many variables you got?
Two.
Good.
6.
Good. Both those answers are right. You guys see that?
You have 2 variables for each set of equations.
Yeah, you either have 2 3-dimensional variables or 6 1-dimensional variables. Doesn't really matter to me. I would look at this and say, there's an equation and there's an equation. And my variables are v and w. Or you can look at it this way. And say that this is 6 equations with 6 variables. I'm gonna take the kind of liberty of assuming that most of you guys are more comfortable with the 6 equations and 6 variables. Is that about right? That's totally legit. It's really like, it's all good. How could you solve this? What do you need to do? How do you solve systems of equations?
You plug variables in after solving them. So I'd go to the right side equations, solve for v on each of them, and plug those v's in on the other side.
Yeah, that's totally legit. You can use substitution. So if you use substitution, you'd change these all to be v1 is 2 plus w1, v2 is 5 plus w2, v3 is 8 plus w3, right? And then you take all that stuff, like we'd take this first thing, and we'd plug it in over here. Right, then we'd get an equation for w1 and we could solve it. You guys see that?
And then couldn't we also do, I think it's called elimination?
We could also do elimination where we looked at these 2 equations So that's kind of another perspective where we might look at the equation v1 plus w1 equals 4. And the kind of sister equation to it, v1 minus w1 is 2. And then we could add these two equations together. See that the w's would cancel. Get 2v1 is 6. Right? You guys all see that? So that's kind of the sister approach. So this is called elimination. The pink approach is called substitution. And the black approach is called lazy, which is where you take your two equations that you had, right? You had v plus w is the vector 4, 5, 6. And the equation v minus w is the vector 2, 5, 8. And you add these equations together. Then the v's cancel, or the w's cancel, and you get 2v is 6, 10, 14 as a vector. So you get v is 3, 5, and 7. You guys see that over here in green, I got v1 is 3. Are these different? Like, are these techniques really different?
No.
No. And that's what we want. Like, this is going to be kind of the punchline of linear algebra is there's a lot of kind of seemingly different algebraic ways to skin this particular cat. And they're all the same. Like they're all equally valid. They're all going to give you the same thing. And we're going to just kind of learn to be comfortable with that fact that they're all the same. You guys good with this? Okay. Questions on how to find W? How would you find W?
You could do 4, 5, 6 minus 3, 5, 7.
Yep. Yeah, just back substitute the 3, 5, 7 you found. I do want to. I'm just going to call this lazy elimination. Because it kind of is, right? It's basically elimination with vectors. And then I just want to note that back substitution is the name of this kind of sub piece of that technique, which is where I say, all right, so 3, 5, 7 plus W equals 4, 5, 6. And then we just subtract. You guys good with that? You could also obtain that via elimination, right? If you multiplied this top equation by -1 and then added them together, the V's would cancel instead of the W's. That would also be fine. You guys good on this? Cody, that hit your question there?
Yeah, I've messed up on a minus sign and
Yeah, so that's why I prefer the lazy thing. I'm much less likely to make an arithmetic error if I'm kind of rocking it all at once. All right, let's see, 28 and 31, 20 or 29 and 31. Oops, sorry.